Welcome to the basics of Matlab. Last session. So in our last session, we have discussed inbuilt functions for algebraic equations, differentiations, limits, higher order derivatives, and solving differential equations also. So in this last session, our focus will be on solving, means what, computing integration of some function, then computing Fourier transforms, Laplace transforms, inverse Fourier transform, inverse Laplace transforms, and some courses, Matlab courses, basics of Matlab, visualization in Matlab, importing and exporting data to and from Matlab. So I'll give some sources where you can get good videos for this Matlab. And the videos that I am showing you are provided by MathWorks itself. They provide many free courses on Matlab. You can go through them. At the end, I will show those courses. But first, let me finish this integration and transforms. So let us start with this integration. So let me define again. Same. Let me define symbolic variables, right? Symbolic variable x. Let me define n. Let me define a. Let me define t. Some symbolic variables I am defining. Let us say if you want to find integration of something, it is very simple. You simply write int. Int stands for integration. That's all. It is not data type. Int is a function for computing the integration. Now you have to supply the function. Let us say you want to supply a function such as n times t, integration of n times t. Simply run it. Right? This is the integral of n times t. Similarly, you can supply any function, integral of a power x, integral of a cos a times cos pi t, something like this, pi times t, all these things. You can simply give the expression to integral this function int, and then it will compute the integral of all these things. This should be pi, not p1. This should be pi. Now it will work without any errors, right? So it will simply compute. If you give a function, it will compute the integral. It will return the result to you, right? So you can write many things here. Let me clear this screen. You can add whatever you want. Integral of cos x, integral of sin x, exponential e power x, integral of e power x, integral of log x. So you can run all these things by simply giving into the int function. That's all. So let me discuss few more things in integral. You can give complex things also, not necessarily very simple. Let us say x power 5 times cos 5x. Whatever you want to give, you can give. It will simply compute. This function will take care of everything, right? It will compute. This is the integral of this function, x power 5 cos 5x, right? So you can give complex equations. It will compute the integral and it will return the result. You can give whatever you want, right? Now we'll see how to compute definite integrals. Let us say you want to compute integral of something between some limits. Then how to give? Let us say you want to compute integral of, let us say, let us take some function x square or something. Let us say integral of x square between -3 and 3. So these are the limits. Definite integral. Integral runs from -3 to 3 x square. So this way you can compute the definite integral also. But you can simply supply extra arguments. You want to compute between minus 3 and 3, you give minus 3 and 3. You want to compute between 1 and 2, you give 1 and 2. Right? That will compute integral of all these things. Right? Similarly, you can give any. I have given simple function. You can give whatever you want. But let me give something else. X cube minus 2 times x plus 5. Let us say 2 times x plus 5. Right? Between 1 and 2. Let us say 1 and 2. You can give between 1 and 2. What is the integral of this function? Right? You got the integral. Right? So this is a simple function int. Using this int, you can compute integral of anything. Right? Now let us say, if you want to, let us say before computing this function, let us say you want to see the plot. We can use easy plot. We have already seen this easy plot, right? Let us say you want to see the plot of x square. You write x square simply. That's all. You give the symbolic expression, it will compute. It will plot the graph for you. You are not giving x and y, right? You can see here. It will plot. This is the expression for what? X cube minus 2x plus 5, because the last plot will remain. So first it will plot this one, then it will be replaced with this one. That's why you got like this. You can remove this because the last plot will remain. Right? So you can compute this integral using this simple int command. So that's all about integral. I don't want to spend much time on integrals. Let me quickly go through these transforms and then I'll finish this session. So, okay, let me clear. Right. Okay. So you can compute Laplace transform, Fourier transform, inverse Laplace transform, inverse Fourier transform by simply using inbuilt commands. So what are the inbuilt commands? Inbuilt commands are also very simple. If you want to compute Laplace transform, simply call a command called Laplace. Right? So let me show you this. Let us say first define some symbolic variables. Right? S, T, A, B, W. Let us say. Now you want to compute Laplace transform of t square. You can compute by simply running this command, Laplace transform of t square. Laplace of transform of t square is 2 by s cube. You can compute all those things, whatever you want to compute. Laplace transform of t power 9. You can compute. Laplace transform of exponent of, let us say, minus b times t. Minus b times t. Let me run whatever we have written. Let me run. You see, it was giving Laplace transform all this thing. Similarly, you can give sine and cos also. Laplace transform of, let us say, sine w times wt. W times t small. It should be small. Similarly, Laplace transform of cos wt, you can give whatever you want. You can give to this Laplace transform. It will simply compute. Simple, medium, complex, all type of expressions you can give, it will simply compute. Similarly, if you want to compute inverse Laplace transform, you simply give inverse Laplace transform. I Laplace, that's all. I Laplace stands for inverse Laplace transform. Suppose you want to compute inverse Laplace transform of 1 by s cube, right? You can compute. This inverse transform also it will work. You see, it is t square by 2. So similarly, you can compute inverse Laplace transform of complex expressions such as inverse Laplace transform of exponent of, let us say, e power minus bt minus b times t. this should be small t. Similarly, you can give inverse Laplace transform of, let us say, s by s square plus s cube, let us say w square. You can compute all these things. You can give some complex expressions, simple expressions, doesn't matter. It will simply compute all these things, inverse Laplace transform. So this is about Laplace transform and inverse Laplace transform. Similarly, we have built-in commands for computing Fourier transforms also. So now let us see how to compute Fourier transform. Let me clear this also. So now how to compute this Fourier transform. So computing Fourier transform is also straightforward. We use a single command, Fourier, it will compute Fourier transform. Now let us see, let me define a symbolic variable x. Now if you want to compute, let us say, the Fourier transform of something, you simply call Fourier transform of the function, let us say x e power minus 2x square minus 2 times x square, simply give x square, that's all. This will give you the Fourier transform of e power minus 2x square, right? You can cross check the results in your system, right? Now if you want to cross check whether it was producing correctly or not, what you can do is, let me define a function first, exponent of minus 2x square, right? This is the function. Now you plot it, easy plot f. Now we have computed Fourier transform, let us save in G. Now plot G also, easy plot G. You can do this way also. Let us say this is f. Okay, easy plot, it will all right. Okay, you see it came. This is the Fourier transform. What is this? 2 power 1 by 2. Okay, first let me show the first one, then I will show this one. What is the Fourier what is the plot of f? The plot of e power minus 2x square is like this. Now what is the plot of Fourier transform? You see the plot of Fourier transform is again same, except the name was changed. Now this is the Fourier transform of e power minus 2x square. So this is the plot of the Fourier transform again, right? So this will tell you that it is in fact giving the correct result. Yeah, obviously it will give correct result. Okay, so this is the Fourier transform. In simply using Fourier command, we can compute Fourier transform. Now suppose you want to compute inverse Fourier transform, right? How to compute inverse Fourier transform? Again, it is simple. Use the command I Fourier. What is this I Fourier will give you? Inverse Fourier transform. Let us say you want to compute inverse Fourier transform of minus 2 exponent of minus absolute of w. Let us say something. You want to compute inverse Fourier transform of this one, it will give you the inverse Fourier transform. This is equal to minus 2 by pi times x square plus 1. So this is the inverse Fourier transform. So these are direct commands. Fourier, I Fourier. Laplace, I Laplace. All these things, they are direct commands. So this is about integration, Laplace transforms, inverse Laplace transforms, Fourier transforms, and inverse Fourier transforms. Now, okay, so I have covered some of the basics in this sequence of pre-recorded lectures. Now let me show you some of the material for learning this Matlab on your own. Suppose you want to go through some of the Matlab basics. If you want some free Matlab courses, let me show you in my account. You can check on your account also. If you have created an account, open your account, go to my account, right? Go to my account. Then here you see, you can check my courses. I have added some courses. I have added this Matlab fundamentals. No need of going through this course itself. You can go to home. Then you see in home, browse self-paced online courses. Browse self-paced online courses. Now here you see, there are many courses here. Getting started with Matlab. That means these are Matlab toolboxes, Simulink, and Matlab courses. So this is the Matlab on-ramp. Get started quickly with the basics. It will cover basics of Matlab. It will cover basics of Simulink. It will cover basics of electronic circuit simulations. It will cover basics of machine learning. Let me open machine learning. It will cover basics of deep learning. It will cover basics of reinforcement learning, image processing, signal processing. So you see optimization. If you are interested in optimization, we have some course for optimization also. This MathWorks. So it was made available by MathWorks team itself, right? Now let me open some courses. You see, these are recorded lectures. You can go through all these things. You see, overview of machine learning, right? Classification, how to import data, how to process data, how to extract features, how to build a model, how to evaluate a model. Everything was there. You can click on something if you want. Overview. Let me go and let me show you how it goes on. So this is the machine learning course, free course that is made available by the Matlab. So you see, this is the organization. Import data, organize data, pre-process the data, extract features, build model, evaluate model, right? You can go to next one. It will show you. It will show. Now you see, this is some handwritten data. Okay, they will give exercises also for you to solve, right? This is import data. What is this? This is classification, exit course. This is for exiting the course, and so on, right? You see, you can go through everything, classification models, model predictions, everything. This is machine learning. Similarly, deep learning. So you will get some basics. You will not get some high-end models in machine learning or deep learning. Since it is a basic course, it will tell you how to load data, how to pre-process data, how to build a model, how to train a model, how to test a model. All these things you will give, right? Similarly, this is deep learning. This is reinforcement learning, right? How to train an agent. All these things was given. Image processing, how to segment an image, how to pre-process an image, how to classify and batch processing in images. This is signal processing, right? Optimization, solving unconstrained optimization problems, solving constrained optimization problems. If you are interested, you can go through and see creating an optimization problem. You see here, you can create optimization models. You can solve using this optimization toolbox. So Matlab has an inbuilt toolbox called optimization toolbox. Using this optimization toolbox, you can solve constrained optimization models, unconstrained optimization models, and so on. So you see, we have a long list of courses, many courses here. Explore our 50 virtual in-person courses. You can explore all these courses. If you are interested in some domain, let us say optimization.
In this chapter, you
can go through those optimization models, right? You will have recordings also, recordings of these things also, how to do all these things. So I suggest you to go through these courses. Similarly, see, there are 4 courses on Matlab. Basics of Matlab itself, Matlab on-ramp, Matlab fundamentals, Matlab for data processing and visualization, Matlab programming, right? Similarly, we have courses for Simulink, We have courses for math and optimization. You see, we have 5 courses for math and optimization. Introduction to symbolic math, solving nonlinear equations, solving ordinary differential equations, introduction to linear algebra, introduction to statistical models. So the organizers has sent a mail saying that this refresher course was for mathematical faculty. So I suggest all the faculty and participants to go through these courses on math and optimization. This will be useful for you, right? So these are the some of the free courses that are available for you to start working with Matlab. Similarly, if you want to solve some optimization models, there are some external tools also. Like we have some tool called IBM Solver, IBM Cplex. The tool name is Cplex. It was not free software. It was proprietary. It was managed and maintained by IBM. So IBM Cplex Studio. So using this IBM Cplex Studio also, you can solve optimization models, but you have to write code and you have to give it to this tool. So the writing of the code can be done in Matlab itself. Although Matlab provides a toolbox, optimization toolbox, you can run the code in our Matlab and you can send the code to the Cplex Studio. The Cplex Studio will solve your optimization models also. Right? Coding can be done in Matlab. So that's all. Thank you. I thank the organizers for inviting me.